2019 Nelson College School exam, differentiation paper, cut-off grades are just there. It's not my best work, under a little bit of time pressure with baby etc. due to arrive last Wednesday, so fingers crossed she arrives tomorrow. But good luck. Any questions, just sing out.
Okay, starting from scratch. If that's a surd, can you differentiate it? No, so we need to make this y equals 5x to the power of a half minus cot of x. So when you're differentiating, what do? Yeah, so you take one off the power, so that's going to be 5 times a half, which is 5 halves. A half minus a half is negative a half. And then what do you do to the cot? When you differentiate cot, looking at your formula sheet, it says minus cosec squared x. Here's my answer, okay? There is a plus in between these two. Well, it's actually a subtraction there, it's actually a minus there, but it's that there is a sum. So it's not a product, so you don't use a product rule, it's a sum. So you're going to do it in two separate parts. Happy with that? If I wanted to write it neatly, I could write down this is 5 over 2 root x plus the cosec squared of x. Happy? Next part would be find the equation to the normal. Okay, so this one's quite a hard question because there's a lot involved in this one. Find the equation. How am I going to find an equation? What am I going to use when I'm trying to find an equation? What formula am I going to use? Yeah, I'm going to use the y minus the y1 equals the m into x minus the x1. Okay. Because it says normal, what does that mean we're going to do with it? Yeah, that means when I find my gradient using dy by dx, my normal gradient is actually the negative reciprocal. That one here, negative the reciprocal of that. Okay. Does that make sense? You remember that? So let's go through and do it. We've got y equals of that. I need to differentiate that. So dy over dx equals, that's going to become 3 lots of x squared minus 4x to the power of 2 times by the derivative inside the bracket, which has become 2x minus 4. And you see how that's in brackets because it's all of that multiplied together. It's not this times 2x minus 4 at the very end. That is a separate bracket. Does that make sense? Do I need to expand to make this nice? No, because all I need to do is find what's the gradient at x equals 3. So at x equals 3, dy by dx equals, that's 9 minus 12. Is that right? That's negative 3 squared is 9 times the 3, that's 27. Too much for my brain at the moment. Times by 2. 2 times 3 is 6 minus 4, so that's times by 2. So that gives me an answer of 54. Yep. So that means the gradient of my normal, the gradient of the normal, therefore, equals negative 1 over 54. Hopefully you remember that from the green up there. And then so it's just y minus y1 equals m into x minus x1. Okay, and you expand it out and make it nice and pretty, and there's your answer. Happy with that? Questions with that?
I just didn't know you had to figure out the y because it just asks in the question to find the equation from the normal. Is that something actually for
This is, well, yeah, because the equation of a line is a straight line, so you need a y equals an mx plus c top back to year 11. At year 13, you're going to use this dark, or this light blue one through the middle. Questions? Other questions? Yep, so I'm not going to read it out again because I just read it out. But anyway, so Sam, you said dd over dt. Over dd over something over dt. Okay, you just have to figure out what that something is going to be. Is that right? That something has sort of tells you in here because that is the number that you're going to have to use, eh? So what is the balloon is, that's h, isn't it? Like if I put an h here, the h of dt, that is 0.3, isn't it? Is that right? So can we now figure out a d over dh? That's what we have to try and figure out, isn't it? Is that right? Happy with that, Luke? So far, so good? So this part here we're saying is, that's my 0.3. And now we have to try and figure out an expression for d in relation to h. Happy with that? So from here, d squared equals 16 squared plus h squared. Happy with that? So that there is the same as, I think 256, correct me if I'm wrong. Is that right? So therefore D is 256 plus h squared, all to the power of a half. Can you see why I've done it to the power of a half as opposed to taking the square root? Yeah, because I want to try and differentiate eventually, yeah. Okay, so that's what I've got to try and differentiate here. So dd over dh equals a half times the bracket, which is 256 plus h squared to the power of a negative a half, times by the one in the bracket, so I'm timesing it by 2h. Happy with that? So that's my dd by dh. Here's my dd by dh. So now all I've got to try and do is go, well, what is dd over dt is equal to a half of 256 plus h squared to the power of negative a half times 2h times 0.3. Put those as times. Happy with that? Happy? And then what I have to do now is just substitute in my h's, don't I? So now I've just got to go, okay, when h, no, sorry, that's dA. So when d is 20, what is h? I need to figure that out so I can substitute in there. How do I figure that out? Pythagoras' theorem, yeah. Or put it into this one here and figure it out from here. Yep. So you're going to go 20 squared minus 16 squared equals something. You're going to take the square root of that answer. What does it give you, please? 12. Oh, that's a 3, 4, 5 triangle. 12. So we're going to go a half times 256 plus 12 squared, all to the power of negative a half, times 2 plus 12 times 0.3. It looks very confusing, but hopefully gives you an answer that is the same as 0.18. From memory, is that right? And that is meters, because this unit is meters per second, because this unit is in seconds. There's my answer. Happy with that? Happy with that? Any questions with that one? Makes sense where we were going? Cool.
Okay, so here's the marking schedule for achieved. You needed to get the correct derivative for part 8. For the second one, you needed the correct derivative and the equation, so you needed to get down to about here for your achieved tick. There you got your other achieved tick. Okay, for this one, if you had got the second, or the correct derivative and the solution, so you got down to here, there's your merit. If you have got to about here, there is your achieved tick.
No, I don't know what's the problem. Anyway, we'll carry on. So I'll just recap what I said. dy by dx, that tells you if it's increasing or decreasing. D squared y over dx squared tells you the concavity of the graph. So make sure we find the concavity, right? So, as again, this is what we just did before the computer looks down on me. So it's going to become 2 sec squared t. Happy with that? So therefore, dt over dx is going to become 1 over 2 sec squared t. And I'll carry on trying to write t. Happy? Right. dy over dt gives you an answer of 4 sec t. Must differentiate to be 4 sec t tan t, wasn't it? Is that right? Happy with that? Okay. So now combining these to get dy by dx. I do that by multiplying dy over dt by dt over dx. That gives me an answer of 4 sec t tan t times 1 over 2 sec squared t. Right. Happy? There's my gradient, eh? Here's my dy by dx. That's my achieved tick. Okay? So even in this one here, this one is one that we can target. Okay, this sort of question. Yeah? Even though it's our excellence question, we should be able to get to some stage along there. From here, if I had gone down the route of maybe trying to simplify that, that's 4 sec t tan t all over 2 sec squared t. If I start to try and simplify this, that's where it starts to get easier for me later on. You don't have to simplify for an achieve, but for your merit and excellence stuff, that actually makes it much easier. Because that there will cancel with one of those, eh? And that 4 and the 2, I'll simplify to give you 2. 1 over sec, that's the same as cos on the top line, eh? Tan is sine over cos. This is now 2 cos t from my sec times sine t over cos t. And as you can see from there, the cos t's will simplify, eh? And you just get a nice round number, or a nice, very pretty looking gradient function. Does that make sense? And for your excellences, they design them so they will end up looking pretty. So from here, what do I need to do? I go, so I differentiate this equation with respect to t, and I multiply that by dt over dx. Okay. Is that from your formula sheet? Can everyone see that on their formula sheet? D squared y over dx squared is the derivative of what we've just done with respect to t times dt over dx. Happy with that? So can we differentiate 2 sine t with respect to t? That just becomes 2 cos t, doesn't it? All right. So this now becomes 2 cos t times dt over dx, which is this one here. 1 over 2, that should be an s, so sec squared t, sec squared t. All those 2's will cancel, won't they? They'll simplify, they'll cancel. Sec squared is the same as cos squared. Cos t times cos squared t, that's just going to give you cos cubed t. Okay, so there's my d squared y over dx squared. Cos cubed t, and all I've got to do now is find when t is pi over 4, cos pi over 4 is formula sheet, cos pi over 4 happens to be 1 over root 2. Is that right? Just for those that are looking a little blank, cos cubed t is the same as cos t cubed. So cos t, cos of pi over 4, on your formula sheets it tells you it's 1 over root 2, hopefully. So at t equals pi over 4, cos cubed t is 1 over root 2 to the power of 3, I believe. And because that answer is positive, it means my graph is concave up. Okay. As d squared y over dx squared is greater than 0, and this is the part, remember, concave up. Okay, so that green part is your excellence. Unfortunately, the navy blue is your achieved, and your, for lack of a better word, royal blue is your merit stuff. Happy? Questions?
You didn't simplify it all the way down to that 2 sine t, and you put it as more complex.
Yeah.
You got the concave up, which is sort of the excellence.
Yeah. No, yeah. From here, the differentiation below the navy blue is very tricky if you do not simplify it. And I think the only way, I think only 2 people got that far. I don't think anyone else was able to simplify it and then differentiate it. But you needed to differentiate that with respect to t, because that there is now a product and a sum in itself, and it just is going to get quite tricky to differentiate with respect to t. Yeah.
Came after and everything kept on out.
Yeah, but again, we're going to be able to follow it, and I think most of the time, to get that far, you're probably guessing.
Okay, for the marking schedule for 1D, the excellence question, if you'd got to about here, That's where most of the boys would have got to. There is your achieve tick. Understanding that this actually simplifies is really important for your merit and excellence after that, because otherwise you're going to have to try and use the chain rule to differentiate from there. And from here you could have actually had 4 sec t tan t 1 over 2 sec squared t as well. That would be okay. Correct derivative, so getting into here, understanding that would be your merit, and then getting your answer and actually saying that it is concave up, that is your excellence tick. Make sure you answer the question. Question 2, right, so differentiate this. So now this is a sum, so here is one we have to differentiate, and this one here separately because it's a sum. This first part is a chain rule, so when I differentiate log, I get 1 over the function, so it's 2x cubed minus 4x squared plus 1, and I have to times that by the derivative of the function, so it's now become 6x squared minus 8x, and then what I'm going to do is differentiate this part here now, so that's just goes to e to the x. Find all the values where there is a point of inflection. So the point of inflection, that is where the second derivative is equal to 0. So I can differentiate once and get half times 4, 2x to the power of 3 minus 3x squared minus 72x plus 5. Second derivative I need to know, so I have to differentiate a second time. 6x squared minus 6x minus 72. Point of inflection, that assumes the second derivative is equal to 0, so now I've got to solve for 6x squared minus 6x minus 72 equals 0. I've got to solve that. I can use my graphics calculator if I have one, or hopefully this here makes sense. Take the common factor of 6 out. From there I'm just still trying to solve, so it's going to be minus 4 and positive 3, which gives me two answers of x equals 4, positive 4, and x equals negative 3. Find the values of x. Here are the values of x. Okay, so Sharon sees a drone flying, so h is height, t is in minutes. We would try and find it for a minimum height. So minimum height suggests that I have to find where the gradient is 0. So if I carry on going here, I'm going to get, I've got this function here. Now this is a function divided by a function, so that is going to be the quotient rule when I differentiate. So the quotient rule says I write down the bottom one times differentiate the top one. Now that is going to be, I'll do it over here just to make sure, that's going to be 2 lots of 5 minus t power of 1 times negative 1. So it's going to become, I'm going to subtract that by write down the top one and times the derivative of the bottom. Then you write down the bottom one and you square it. And then yeah, okay, cool. So from here, where does h dash t equal 0 implies that the top line, which is t plus 3 times negative 2 lots of t minus, 5 minus t, minus 5 minus t all squared equals 0. So I'm just going to expand all this stuff out, okay, and collect them all. So that's going to become negative 2t minus 6 was 5 minus t minus 25 in brackets minus 10 lots of t plus t squared equals 0. It's going to become negative 10t plus 2t squared minus 30 positive 6t minusing 25, adding on 10t, minusing a t squared, and that all equals 0. That all is because I've multiplied by that negative through there. Collecting my like terms, like gives me t squared, like, this just gives me positive 6t, and that's going to become, well, like and like, so that's going to become negative 55 equals 0. Now I have to factorise that. That's become t plus 11, t minus 5 equals 0. So that suggests that t is 5 or negative 11. But t cannot be negative 11 because you can't have a negative time. So t therefore is 5 minutes. And looking at the marking schedule for part A, part B and part C, you can see here part A, a lot of people forgot that it was the chain rule. Okay, so you really needed that for your achieved. Obviously all of it for achieved, but that was the key thing that we forgot. Correct solutions, so you needed to find these parts here. Okay, the key thing was setting that second derivative to be equal to 0. Correct derivative, if you could use the quotient rule to give me an answer like that. There's your achieved skill, and your merit was getting you 2 solutions, excluding the negative answer, so after 5. That's obviously wrong, that should be in minutes. Okay, so the actual question here, so I've had a bit of an issue, so I'm going to show the answers because the answers actually show what we're doing here. So if I was to do this one, what I would do is I'd look at my function and I would differentiate that. When I differentiate that, what I've got is I've got the product rule. I've got my first function, I've got f and g. When I'm doing the product rule, I write down my first and I differentiate my second. And I write down my second, differentiate my first. So there is my dy by dx, which I can write nice and neatly like that. Okay, get that right, and I get my u tick. Okay, from here is my u tick. And because I need my second derivative here, I'm going to do that. So I'm going to derive this function here. So again, it's just a combination of 2 product rules. So here is one product, here is f, and here is g, and here is my second product, f and g. So again, with 2 lines, you can see there's my first product rule, and here is my second product rule. So write down the first, differentiate the second. Write down the second, differentiate the first. And because I would usually be a plus there, but plus the negative makes it a straight minus. And the same here, so I'm going to write down the first, differentiate the second, write down the second, differentiate the first. And what happens is when I collect that, I've got this nice untitled little answer just here. So that when I add this one and this one, what I notice, alright, so I've got ke to the negative x cos kx minus e to the negative x sine kx, that's dy by dx, when I add that to negative k squared e to the negative x sine kx minus 2k e to the negative x cos x, so cos k, which should be cos kx, plus e to the negative x, where have I got the k's here, k sine kx. I'm going to do that. This one here cancels, and this one here cancels. So one of those ones there will cancel with one of these ones over here. The sine ones cancel, I believe, and you're left with this and one of these, which when we add the one here will cancel with the other one, which leaves you just with this one just here. And since y is up here, c becomes negative k squared. Negative k squared. Do that again. C is negative k squared. That's quite a tricky question. So, but I'll bring here first. Right. Next one. Question 3. Differentiate. There is a quotient rule again. So with the quotient rule, there's f and g based on my formula. Dy by dx is g times the differential of f, which is going to be 3 lots of e to the 2x times 2 minus f 3e to the 2x times the differential of g, which is 3x squared, all divided by g squared. There's my answer. Next one, if the distance of a particle travelling is given by this function, where the distance is in meters, times in seconds, find the acceleration after 2 seconds. Okay, so I need to find a2. Now, remember, if I've got distance with respect to time, getting to velocity is differentiation, getting to acceleration is again differentiation. St equals e to 2t minus 5t squared, so s dash t, the derivative of that, which is actually the velocity, is 2e to the 2t minus 10t. And so again, the differentiate velocity, which is actually the second derivative of the distance, which is my acceleration function, is 4e to the 2t minus 10 at t equals 2. Acceleration of 2 is 4 lots of e to the power of 2 times 2, which is 4, minus 10. And I don't have a calculator on me, sorry, to answer that, but put that into your calculator and I'll give you an answer, which should be in a couple of slides. Okay, well these ones here, well, where is the function? Oh, these graphs are going to come up, so we need to know these ones. Okay, and it's by colour, it's actually a bit easier to see the different functions here, but yours won't be in colour. Where is a function continuous but not differentiable? Here. The function is not continuous here, nor is it continuous here. So it's just the one answer. Where is the gradient less than 0? Where is the function decreasing? The function's decreasing between here and here. So we're going to say roughly 2.5 between x and 5.5. Any other places where it's decreasing? Oh, we'll go between here and here as well. So between 0 and 1 as well. where is the gradient 0? So that's where we're looking for turning points there. So I'll change colour. So here, where is the turning point? So a turning point here and a turning point here. So for this answer, I would get x is equal to 2.5 or x is equal to 5.5. But here we're talking about a second derivative is less than 0, so it's concave down, a negative graph. So the derivative is less than that, which gives us our answer of just this one here. Hopefully that makes sense. I probably didn't explain that very well. Where is my function less than 0? Less than 0 between here and here, so that's just between 5 and 6. And the last one, what is the limit as x approaches to a of a function is not the same as the function? Just here, isn't it? The limit as x approaches a of the function is -2. The value of the function is 1. Hold on, that doesn't make sense. Doesn't explain that very well at all either. A is -2. The limit as x approaches -2 of the function is like a half. The value of the function at -2 is 1. A half does not equal 1. Sorry, that's what I meant to say. Hopefully that makes sense. Alright, so a few things to talk about here. Correct derivative, no need to simplify. You didn't need to put that one there, but yeah. So the answer to 4e to 4 minus 10 was this one. Okay, so hopefully that makes sense. Correct solution as well. Answers x equals 1, between 0 and 1, and 2.5, 4.5. You didn't need to put the approximately part. They're fine, you can just put 2.5, it's not an issue. And again, looking at the marking schedule, 2 out of 5 for an achieve tick, 3 out of 5 for a merit tick. Pretty, yeah, I think we should be targeting that stuff. Okay, final question. Excuse me. Triangle described as a semicircle, radius r. One vertex lies at the center of the circle. And the other two vertices P and Q. Find the dimensions of the triangle where the area is maximum. Okay, so the area of a triangle is going to be area of half times the base times the height. Okay, in this case, on my circle, it's going to be a half times 2 lots of x, because that there is x. So there is going to be 2x times my height, which is y. So in other words, it's just going to be x times y. Okay, now that's what I'm trying to maximize, so that's what I have to differentiate. But what I need to be able to do is form an equation where y is a function of x. So on my circle, x squared plus y squared is r squared. So therefore y squared is r squared minus x squared. So y is actually r squared minus x squared all to the power of a half. Why do I leave it as a half? Because it's easier to differentiate. So from here, my area function is actually x lots of r squared minus x squared all to the power of a half. Okay, so from here, what I need to do is I need to differentiate my area with respect to my x. Again, that is a product. So there is f, there is g. Product, I'm going to need more space. So what I'm going to do is I'm going to write this one over here. So dA over dx is going to be right down the first, which is x, times differentiate the second. That's the chain rule. It's going to be a half, lots of r squared minus x squared, all to the power of negative a half, times the differential in the bracket, which is negative 2x, plus write down the second derivative, r squared minus x squared, all the power of a half times 1. Okay, so tidying this up, a half times 2 is 1, x times x, that's going to become negative x squared over r squared minus x squared to the power of a half, plus, that's going to be r squared, not plus, sorry, minus x squared, all to the power of a half. Now the maximum suggests that my dA by dx is 0. So now I've just got to solve whether this is equal to 0. It looks pretty tricky, but if I try and have these fractions as same denominator, times this fraction by 1 in the form of r squared minus x squared all to the power of a half, that there means I've got a common denominator. This part here is actually this times itself, so it's actually that squared, which means I've actually got negative x squared plus r squared minus x squared to the power of a half squared all over r squared minus x squared all to the power of a half. Okay, and if we're talking about dA over dx is equal to 0, we're just really referring to that top line. And a half to the power of 2, they're going to simplify. So we're going to get 0 equals negative x squared plus r squared minus x squared. Trying to solve that, we've got that is equal to negative 2x squared plus r squared. So 2x squared is equal to r squared. So from here we're going to get x squared is going to be equal to half of r squared. So therefore x is going to be equal to the square root of a half r squared, which is just going to be a quarter of r. So if, no, that's not right, sorry, that's not a quarter, is it? No, that's 1 over root 2, sorry. Apologies. 1 over root 2, a half times a half. So half squared is a quarter, not square root of it. So there's my answer. So if x is that, what is y? How do I find my y? Y is here, isn't it? Y is in here, so y is equal to r squared minus x squared, which is here, minus a half r squared, all square rooted, which is actually a half r squared, square rooted, which is actually going to be the same thing, isn't it? Over 1 over root 2r. Alright, plus and minus, because here's my plus and here's my minus. And then what's my area? So my area is equal to x times y, so it's 1 over root 2r times 1 over root 2r, which happens to be 1 over 2r squared. There's my area. Geez, that's a lot. Looking at the marking schedule, where are we going here? Correct derivatives. If you can find the area function and then derive that, you get your achieved tick. Set it for 0 when trying to solve a solution. In here, you get 1. You get your merit tick. Finding y as well, therefore giving you the dimensions. I mean, I didn't actually give the dimensions, did I? I didn't give the height or the base. I just gave x, y, and area. So hopefully that makes sense anyway. Bear in mind that my x, which was 1 over root 2r, is not actually the dimension of the base. So I needed to times that by 2 to get my base. Yeah, so I wouldn't have got an excellence on that question, but hopefully that makes sense. The error you can see that I made, you guys can make anyway. So again, that's it. Hope it makes sense. Good luck. Any questions, let me know.